Consider the equation x squared plus 1 equals 0. Rearranging it leaves us searching for a number whose square is -1. Looking at a standard number line, we see the issue. Squaring +1 gives 1, and squaring -1 also gives 1. Real numbers never square to a negative. To find a solution, we introduce a second dimension. This horizontal line represents real numbers. By rotating our unit arrow 90 degrees, we leave the real line. We call this the imaginary axis, defined by the unit I. Another rotation brings us to -1, so I squared equals -1. We define I as the square root of -1. This concept serves as the complex foundation for modern math, unlocking a whole new world of numbers. Today, we are exploring the anatomy of complex numbers. A complex number is typically expressed as z equals a plus bi. The component a is what we call the real part. In contrast, the component bi is known as the imaginary part. We can visualize these values on a coordinate system where the horizontal axis is real and the vertical axis is imaginary. To plot a number, we first determine the horizontal distance, such as moving 4 units east from the origin. Next, we account for the imaginary portion by moving 2 units north along the vertical direction. This final position represents the complex number 4 plus 2i, combining both real and imaginary dimensions into a single point on the plane. Today, we explore quadratic equations with negative discriminants. Recall that the discriminant is b squared minus 4ac. Here, the value is less than 0. Graphically, a negative discriminant means the parabola never touches the x-axis. This gap shows there are no real solutions to the equation. To find our roots, we must enter the imaginary plane. This space is defined by the unit I, the square root of -1. In the quadratic formula, a discriminant like -16 results in 4i. These paired solutions are called complex conjugates, written as p plus or minus qi. In the complex plane, these roots are symmetric reflections, completing the picture of our quadratic solutions.